Okay, kids, this is it, our last little lesson on volumes, and we are now no longer going to be rotating regions about the x and y axis. No siree, we will be rotating regions about x equals any old number or y equals any old number. So these are still, vertical and horizontal rotations. They just will be about lines other than the x and y axis. The key to doing these problems is going to be that you make a good drawing, and then you can get big R and little r off of these drawings. Because almost all of these guys will end up being washer method. And so you need to have a good sense of what big R and little r are. And so that requires a good drawing. So here we go.
Mr. Shane?
Yes?
Will we be required to have drawings on our test?
No.
Okay.
No, however, if you're such a three-dimensional spatial genius that you can just picture it in your head or something, I'm not going to argue with that. But in my opinion, your chances of getting a right answer are greatly increased with a good drawing. Okay, here we go. So I've got, here's example 1. Y equals x squared, y equals 4, x equals 0 is revolved about y equals 4. So I'm going to get the region bounded by y equals x squared, y equals 4, and x equals 0, and revolve that about y equals 4. Here we go. Okay. Here's my parabola. Here's y equals 4. Here's x equals 0. So I hope you guys get that this is my region of interest. Now, that region is going to get revolved about the line y equal 4. Okay. So let's go ahead and revolve it. So this point stays on the mirror. This point goes 4 up, 5, 6, 7, 8. So this point goes up, and this point, since it's 3 away from the mirror, it has to be 3 away from the mirror. Okay. So I have revolved this region about the line y equals 4. So I get, this sort of thing. I don't know what you would call that. Like a coconut? Like half of a coconut? Okay, cool. Or maybe it's not a Hershey's Kiss because the concavity is wrong. I don't know, maybe it's
Looks like
like what? Oh, paper hat, yeah, paper hat. Well, regardless of what it is, let's go ahead and get some discs here.
Mr. Shane, that looks like a bullet.
A bullet?
Yeah.
Wow. You really are into guns and things, aren't you? Looks like a bullet. Okay. Well, anyway, so I've got disc method going on here. It is now time for me to get the radius of one of my representative discs. And there are two recommendations I must make in getting your radii, okay? When getting radii, big R or big R and little r, number 1, always make your measurements with the original region. You notice I've got my original region, and I've got the region I get upon reflection. Well, do all your measurements on the original region, or you get confused. So make measurements on the original region, not the reflected one. And the second recommendation, or the second thing I must remind you of, all radii are measured relative to the axis of rotation. Okay? All radii measured relative to axis of rotation. all radii measured from axis of rotation. So like, look at this disk here. The thickness is dx, correct? Can I just say the radius is y? Is the radius for this disk here y? Well, I'll tell you, when we say y, we're talking about the y coordinate of this graph, correct?
Yeah.
And the y coordinate of that graph goes from here to here. That's y.
Yeah.
So my radius isn't y. My radius is the distance from there to there. Okay? Well, from here to here is 4. From there to there is the y coordinate of this graph. Not there to there. Here to here is the y coordinate of the graph. That's 4. So what's my r going to have to be?
4 minus 1.
If you're thinking 4 minus y, you win. And now you see why it's so important to have a good drawing. I don't think you get that without a good drawing. Without being able to look at a drawing and observe, oh, my radius isn't y. It's 4 minus y. So let's go for it now. So my differential volume is going to be pi times 4 minus y times, what is it, dx? Oh, 4 minus y squared dx, because it's pi r squared, right? So I got 4 minus y dx, and now I'm going to have to convert that. Are you okay that y is equal to x squared? So my differential volume is pi times 4 minus x squared dx. And so the volume ends up being the integral of pi times 4 minus x squared dx. And my bounds, hopefully you see that since I'm in dx land, my bounds are going to have to be from 0 to 2. That is, I'm adding disks from left to right. And then you punch it in your calculator and get the answer. Any question or problem on that? Then hey, it's time for you guys to do one. Example number 2. Region bounded by y equals x squared, y equals 0, and x equals 2 is revolved about the line y equals 6. Good luck. And this will be a washer method problem. Let's see if you guys can get this. by now, hopefully you're getting close to having a good drawing. And then let's see if you can figure out what big R and little r are. Because that's it, that's the only part that requires intelligence. Yeah.
Why did you want to do the washing method? Because I'm just gonna do this with it.
Well, because when I made my drawing, these are all discs. But when I make these drawings, these are all washers.
Oh, but like, couldn't you do the same thing over here? Because like, I don't, because you know how you like have the region where you shaded it?
Yeah.
Like,
Yeah, but since both shaded regions are right up next to each other, there's no hole here. This is like a solid bullet, you know? Whereas here, like the only way I could do washer method with something like that would be if like the region looked like this, but then I revolved it about some line like that.
I get it. I was looking at the drawing. Sorry.
Okay, no, good, thanks for asking. Yes. If anyone gets big R and little r, I will fall over dead. We're getting some really nice drawings, though. Wow. Your drawings are getting better. Look at that 58. Get big R and little r. Once you get the drawing, that's all you gotta do. Nice drawing. Let's get big R and little r. Little r. Sandra, you are very slow. Or asleep. I think he's asleep.
Oh, I messed up.
Okay.
Sorry.
Ooh, nice looking drawing. Good for you, Erica. You got big R. Good for you. What did you get for big R?
I'll give you like 12.
Well, actually, it has to be measured from the axis of rotation. Yeah, good for you. Yeah, I think we're getting the right answers. It's shocking. We're gonna fall over dead. Keep going. Find big R and little r. Oh, you're so smart. And little r. Now, little r is the distance from there to there. And that's not y. Let's see if you do that. Yeah, same thing. Little r is the distance from there to there. Y is the distance from there to there. So your little r can't be y, which you're calling x squared. Little r can't be y, because that's the distance from there to there. You need the distance from there to there. So let's see if you can figure that out. Could you? Oh, you're still on it. Okay. Again, little r, whoops, you're correct. Laura, you're correct. I was about to tell you were totally wrong, but no, you're correct. Oh, no, so smart. You're so smart. Your big R is correct. Yeah, just agonize with it, because there's not much more for me to tell you. Yes? Sure. You've got to go, I figured it's not that time. Hmm? He said go for big R and little r. Big R is, okay, yeah, you're correct. That's beautiful. Here's the thing. Little r isn't y. Little r is the distance from there to there. Y is the distance from there to there. But you don't want the distance from there to there. You want the distance from there to there. Okay, hey guys. Let's go ahead and take a look at this, because I want to have time to do one or maybe even two more. Big R, I want to remind you, number one, make measurements on the original region. This is the original region right there, correct? So make all your measurements relative to the original region. Number two, all radii are measured from the axis of rotation. Well, big R, almost everyone is getting big R. Every single washer you'd make has an outer radius of 6. So pretty much everyone's getting big R, and I'm very happy about that. The next part is little r, and little r is the distance from there to there. That's little r, okay? Now, I have a lot of people saying that little r equals y. But little r can't be y, because y is the distance from there to there. Y is the distance from the x-axis to the graph. That's not y. I mean, that's y, but that's not little r. Little r is from the axis of rotation to the graph. Well, I hope you see that from there to there is 6, from there to there is y. I hope you get that little r has to be 6 minus y. So there it is. Little r is 6 minus y. Any question or problem on little r being 6 minus y, which ends up being 6 minus x squared? Yes? Okay. All right, then hey, let's go ahead and get our differential volume. It'll be pi times 6 squared minus 6 minus y squared dx. We're in dx land. So I need to change that y into an x. So v will be the integral of pi times 36 minus 6 minus x squared squared dx. And now I'm going to integrate along the x-axis from 0 to 2. How many people actually got that answer? Oh, good for you guys. Good. Wow, okay, well, I mean, okay. All right, hey, let's do another one. Okay. Let's see how much you guys like dy land. Here comes example number 3. Same region as example number 2. So it's that same region, but now you're going to revolve it about x equals 3. Revolved about the line x equals 3. Good luck. Let's see if we can get this one. Get small, once you draw it, get small r and big R. Let's see see what you guys get.
It's like a volcano project.
Yeah, I mean, all I need is some baking soda and vinegar. We got it going on. Okay, hey you guys, what's small r? 1. How do I know? Because every washer I choose, the inner radius is going to be 1, and I only know it from the drawing, you know? Big R, is big R X? What is big R?
3 minus.
Yeah, 3 minus X. Because if I say big R is X, hey, the distance from there to there is X. That's the X coordinate on this graph. I don't want the X coordinate on this graph. I want the distance from there to there, big R. Well, from there to there is 3. From there to there is X. So I hope you get that your big R is 3 minus X. Now, I am in dy land, so I can't keep it as 3 minus X. So I'm going to have to do 3 minus, what'd you guys put for that?
Rad y.
Yeah, rad y. Since y equals x squared, rad y equals x. You're going to have to put 3 minus rad y. Yeah, so your volume ends up being the integral of pi times 3 minus rad y squared. This is before the well, rad y squared minus 1 squared dy. And then I'll go from 0. What should I go? 0 where? Yeah, 0 to 4. I'm in dy land. I got to go along the y-axis. All right, hey, good luck on tonight's homework. Your last homework assignment of the year. Yes.